All right, in these next problems, and from here on out, actually, we're going to need to be looking at whether or not the order in which you complete an event or make a selection or a choice has any bearing whatsoever on the outcome. So, for example, let's say you order a 4-topping pizza. When you place that order and you say, I want pepperoni, sausage, mushroom, and onion, does that really matter, or could you have just as easily said onion, sausage, mushroom, and pepperoni? Well, obviously, the 4 toppings you get on your pizza are all going to be there, regardless of the order in which you placed that order. And so, no, the order doesn't matter. If you create a 5-digit code for your garage door, does the order in which you selected those digits matter? So, in other words, when you go back to open your garage door later, do you get to put those 5 numbers in any order you want, or do you need to put them in the specific order in which you selected them in the first place? And again, here, a specific order is going to be important. So yes, order matters. If 3 people are given a raise at work, and those raise amounts are different, 15 cents, 25 cents, and 35 cents an hour, does it matter if you're one of those 3 people getting a raise, which one of those raises you're given? I would think so. Although you'll be happy for a raise, you'd be happiest if you got the largest raise. And then finally, 3 people are given a raise at work and everybody's just going to get 25 cents an hour. Well, in this case, the order won't matter, because if you're one of the 3 people listed, whether your name was called first, second, or third, you get the same benefit regardless. Sorry, that should be a no. So their order does not matter. So hopefully, again, we found some examples where order wasn't important, and let's see what that does to the number of possible outcomes. So up to this point, we've been using the basic counting principle or permutations to solve problems. So now what we're going to do is see what happens if the order actually doesn't make any difference. So let's say we have people or person A, B, and C, and they're all going to get a raise for a different amount of money. So let's say the first person listed gets the lowest amount and the last person listed gets the highest amount. So whenever we start listing the ways that could happen, it could be person A, B, C. It could be person A, C, B. B could be the lowest, followed by A and C. B could be the lowest, followed by C and A. Or C could be the lowest amount, followed by A and B. Or we could have CBA. And so there are 6 different ways that those 3 people could each get a raise in a different amount. But if they get the same raise, notice that every one of those 6 things that we just wrote down are the same group of 3 people. In other words, there would only be one way for that to happen. Those 3 people are the ones who get the same raise. So how does that number of outcomes when order matters compared to the outcomes when order doesn't matter? Well, when order matters, there are more outcomes. Than when order doesn't matter. Okay? And if you think about it, in terms of will this always be the case? So if you need to call up a group of 5 people and the order somehow matters, is there one way to do that, or are there lots and lots and lots of ways to do that? Okay, and if you're just going to call up 5 people because they're all going to get the same, say, $15 gift certificate to the same store, there's really only one way for that to happen. You can call those 5 people. If all those gift certificate amounts were different, there would be more ways. So yes, it is indeed always the case that when order matters, there are more ways to do something than when order doesn't. So when order does not matter, this is what is known as a combination. And again, we're not going to emphasize so much that formula that's there. Your calculator has an NCR button in the same place you found your factorial and your permutation button. But what is going to be very important to us is when do we use a combination. So combinations, just like permutations, can have no repetition. But in this case, the order of selection does not make any difference. So the order does not matter. So let's put this into action and see how this would actually work. So a group of 14 students is chosen from a class of 25 students to pass out art supplies. In how many ways can this be done? Now, first, what I'm going to have you do is think about this overall, not just the fact that it's a combination problem under the combination heading, but does it really matter the order in which you select these 4 students to help pass out supplies? No, there's no benefit to being first versus the last one chosen. So that's how you know to use a combination. The first number in your combination is the total number of students, in this case, that are available to be chosen. And then you want to use a C for combination. I will use choose, so 25 choose. And then how many people out of that 25 do we have to choose? Well, we're going to choose 4 students to help pass out supplies for a total of 12,650 different ways we could select those 4 students to be helpers. All right, back to the pizza example. We're going to order a 3-topping pizza from our favorite restaurant. We're going to pick 3 different toppings, so no like double pepperoni or anything like that. And there are 17 toppings available. So we've already discussed the fact that ordering a pizza, the order doesn't matter, that you list the toppings. So the first number is how many toppings are available, 17. Choose, and we're going to pick 3 to put on our pizza. There would be 680 different pizzas you could order.